All right, so now we are going to be looking at two methods of calculating the brake power of an engine. In some of the problems that you're going to be doing, they won't always give the brake power of the engine, but what they'll do is they'll give you additional information, and you're going to have to be able to identify which test has been done. In some cases, they'll even tell you which test has been done. And there's two formulas here that we're going to have to just quickly look at. So the tests, firstly, the first one we're going to look at is called the rope brake test, which is using a rope as a brake on the flywheel, right? And that's done so that they can calculate the brake power of the engine. The second one is what's called the Proney brake, and that is where they use two wooden blocks or wooden brake shoes to be able to apply a braking force to the flywheel so that the brake power of the engine can be calculated. All right, so these are the two formulas. This top one here is for the rope brake test, and this bottom one here is for the Proney brake. And I've indicated to you what each part of the formula means, so you can see that. And I just want to quickly just give you a brief introduction of what this thing looks like. So firstly, here's the rope brake, and you can see there's a rope wound around this flywheel. On this end here, you have a weight or dead weight that's pulling down, and the engine is rotating in the opposite direction. And you can see on this side here, there's a spring or a scale. So I've actually got one here, so you can see. So I don't know if you can see that very well, but you can see as you pull on the one side, it will give you a reading in newtons, and then you can calculate the amount of kilograms that's being applied. All right, so you also need to know what the diameter of the flywheel is, and you need to know what the diameter of the rope is, so that even though it's just very it's very small, the rope, you have to still take that into account. All right, so that's the rope brake test. All right, and you can see here on the formula, you've got N for the number of revolutions per minute. You got the torque. You see M there. M is the mass of the dead weight. That's the weight over here, that mass. You got the scale reading in kilograms, so that's from the scale over there. Remember, scale. Then we have the gravitational constant. We have the diameter of the flywheel, so that's the diameter of the flywheel, and then we have the diameter of the rope. All right. So that's what they're going to have to give you, and then you can plug that into the formula and calculate the brake power before you continue with the calculations like normal. So that's the rope brake test. All right, and the second one is what we call the Proney brake. All right, and it's very similar. It's just instead of a rope, they are using brake shoes. Okay, so there's an arm, there's a weight, and there are the brake shoes that's pressing down onto the flywheel. Okay, and we just look at the formula quickly. Again, we got the engine speed in revolutions per minute. We got the effective length, so that's the length of the arm. So, there we go. There's the length of the arm. They need to give you that in meters. And then the mass that's applied to that arm there, the mass is on the end there. And then we have the gravitational constant again. And again, you just plug it into the formula and you'll have the brake power, and then you can continue with the calculation. So I hope that helps you guys.